Alright, so now let's talk about whether every function has an inverse or not. So let's go back to the same kind of problem that I started off with when we did the first video talking about what's a function and what's an inverse. So let's make up a new function. So here's my new function, and it's getting near holiday season, so I'm going to do some baking. So I'm going to make some cookies. So step one, I'm going to get my ingredients. Step two, I'm going to mix it all together because I'm making cookies. Step three, I'm going to bake my cookies. And step four, I'm going to eat and enjoy my cookies. There's my function. So let's make an inverse. So to be an inverse, there we go. I'm going to start with the eat and enjoy, but I'm going to do it in reverse order, and right away I'm not sure how I uneat and unenjoy. And then if I could even figure that out, the next step would be to unbake. Not sure how I would unbake. The third step would be to unmix together. I'm not sure how I would do that. So the point of this little exercise is to show that even though I can make a function out of baking cookies, I can't have an inverse. So not every function has an inverse. So what makes a function have an inverse? Okay, we'll get to this table in a second here. So in order to have something be a function, remember our definition of to be a function, you had to have a unique input for every output. Okay, that was one criteria. And the second one is it had to pass the vertical line test. Vertical line test. Okay, so what we're going to do now is we are going to make our definition of function even more restrictive, so to speak. So in order for a function to have an inverse, first of all, it has to be a function, so it has to have a unique input for every output, and it also has to have, so every output had a unique input. Okay, so I need a unique input for every output, and in addition, I need make sure that every output had a unique input, and it also has to pass a horizontal line test. And I'll demonstrate that in a minute. So the definition of a unique input for every output, and every output had a unique input, means this is a one-to-one function. That's what we call it, one-to-one. 1 to 1. So one input, one output, and one output, one input. Let's look at the data table a minute. So this first one, is this a function? So when I put in -3, I'm right here, and I get out 9, good. And I put in 3 and I get out 9. So this is a function, right? Because I'm not putting in -3 and getting out 10. So I didn't do that. So all of my unique inputs resulted in outputs. So that was good. So that's a function. But does this have an inverse? So that would mean, this is the table of the inverse right here, so that would mean when I put in 9, well, what would come out? Would -3 come out? Or would +3 come out? Because look, both -3 and +3 as an input to the function give an output of 9. That's okay to be a function, but to be an inverse, well, I can't have two different outputs. To be an inverse, that means if I put in 9, I can only get out -3, or I can only get out +3. And that's certainly not the case of this. So this is an example of looking at a table and determining that this is not a one-to-one function. Let's look at a graph a minute. So right here I have a graph of a line, and let's make red be our vertical line test. So it passes a vertical line test, so it's a function. And we'll let this color be our horizontal line test. So here's my horizontal line, and when I draw a horizontal line on here, it passes through the line in one place. So this is a function, and it has an inverse. So then we say this is 1 to 1. So it's a one-to-one function. Let's look at the parabola on the right over here a minute. And we already know that it's a function. Passes the vertical line test. That's a function. That's great. Now, horizontal line test. Here's my horizontal line. Oh, and look what happened here. It intersected in two spots. So this is a function, but it does not have an inverse. So it's not one-to-one. It does not have an inverse. And this is the end of this video, and in the next video I'm going to show you how to make this function have an inverse by restricting the domain.